Question 1. What is the primary purpose of prompt engineering in the context of large language models, LLMs? Option A. To train a new LLM from scratch. Option B. To fine-tune an LLM on a specific dataset. Option C. To craft effective inputs to guide LLMs to produce desired outputs. Option D. To develop the underlying neural network architecture of an LLM. The correct answer is to craft effective inputs to guide LLMs to produce desired outputs. Here's the explanation. The overview defines prompt engineering as the art and science of crafting effective inputs, known as prompts, to guide large language models, LLMs, to produce desired, accurate, and relevant outputs. Question 2. When designing a prompt for a complex task or specific formatting requirement, including one or more input-output examples within the prompt, is known as what technique? Option A. Zero-shot prompting. Option B. Chain-of-thought prompting. Option C. Few-shot prompting. Option D. Iterative prompting. The correct answer is few-shot prompting. Here's the explanation. The key features components, section lists, examples, few-shot prompting, including one or more input-output examples within the prompt to demonstrate the desired behavior. Question 3. Which model parameter directly influences the randomness or creativity of an LLM's output? Option A. Max tokens. Option B. Stop sequences. Option C. Temperature. Option D. Top_K. The correct answer is temperature. Here's the explanation. The key features/components section defines temperature parameter, a model parameter that controls the randomness or creativity of the output. Higher temperatures lead to more varied and imaginative responses, while lower temperatures result in more deterministic and focused outputs. Question 4. Which of the following is a defining characteristic of large language models, LLMs? Option A. They typically comprise only a few thousand parameters. Option B. They are primarily based on traditional rule-based programming. Option C. They utilize the transformer neural network architecture and are trained on massive datasets. Option D. They are exclusively used for simple classification tasks without generation. The correct answer is, quote, they utilize the transformer neural network architecture and are trained on massive datasets. Here's the explanation. LLMs are characterized by their immense scale, billions, trillions of parameters, and their foundation on the transformer neural network architecture, pre-trained on vast datasets. Options A, B, and D describe characteristics contrary to LLMs. Question 5. In the context of LLMs, what is the primary purpose of tokenization? Option A. To fine-tune the model for specific tasks after pre-training. Option B. To break down raw text into smaller, manageable units that the model can process numerically. Option C. To define the maximum number of words an LLM can remember in a sequence. Option D. To generate new, coherent text based on a given prompt. The correct answer is to break down raw text into smaller, manageable units that the model can process numerically. Here's the explanation. Tokenization is the critical first step in both training and inference, where raw text is converted into tokens, words, subwords, characters, that the LLM can process numerically. The other options describe fine-tuning, context window, and generative capabilities, respectively. Question 6. What is the main difference between pre-training and fine-tuning an LLM? Option A. Pre-training uses a small, labeled dataset, while fine-tuning uses a large, unlabeled dataset. Option B. Pre-training focuses on learning general language patterns, while fine-tuning adapts the model for specific tasks. Option C. Pre-training adjusts the model's weights, while fine-tuning only involves crafting prompts. Option D. Pre-training is performed only by end users, while fine-tuning is done by model developers. The correct answer is pre-training focuses on learning general language patterns, while fine-tuning adapts the model for specific tasks. Here's the explanation. Pre-training involves unsupervised learning on diverse, large datasets to acquire general language understanding. Fine-tuning is subsequent supervised training on smaller, task-specific datasets to specialize the model for particular applications. Prompt engineering, mentioned in option C, is an alternative to fine-tuning that doesn't alter model weights. Question 7. What is the fundamental capability that defines text generation in artificial intelligence? Option A. The ability to classify existing text into predefined categories. Option B. The ability to analyze the emotional tone or sentiment of a text. Option C. The ability to produce new, human-like text based on a given prompt or context. Option D. The ability to extract specific entities like names, locations, and organizations from text. The correct answer is, quote, the ability to produce new, human-like text based on a given prompt or context. Here's the explanation. Text generation is a generative AI task focused on creating novel, coherent, and contextually relevant text. Options A, B, and D describe text classification, sentiment analysis, and named entity recognition, which are discriminative NLP tasks. Question 8. Which technique involves carefully crafting input queries to guide a large language model, LLM, to generate the desired output, often without modifying the model's underlying weights? Option A. Fine-tuning. Option B. Tokenization. Option C. Prompt engineering. Option D. Context window adjustment. The correct answer is prompt engineering. Here's the explanation. Prompt engineering is the strategic design of input prompts to elicit specific and high-quality responses from pre-trained LLMs. Fine-tuning involves retraining the model weights. Tokenization is text conversion, and context window is a model limit. Question 9. When deploying text generation models in a cloud environment for customer-facing applications, which ethical consideration is most critical to manage and mitigate? Option A. Ensuring the model can only generate text in a single, predefined language. Option B. Limiting the model's ability to process documents exceeding a certain length. Option C. Addressing potential biases, hallucinations, factually incorrect information, and privacy concerns in the generated output. Option D. Restricting the model to only utilize extractive summarization techniques for content creation. The correct answer is addressing potential biases, hallucinations, factually incorrect information, and privacy concerns in the generated output. Here's the explanation. Ethical considerations like bias, hallucinations, generating false information, and privacy are paramount for text generation models, especially in customer-facing roles, as they can lead to misinformation, unfair treatment, or data breaches. Other options are technical limitations or unrelated concepts. Thanks for watching. Please subscribe to my channel.